Hello, and welcome back to part 2 of this series where I teach you how to run factory I/O scenes via PLC programming in CODESYS. My name is Will, and today we are going to be covering scene 2 in factory I/O with a few modifications. This scene involves some new concepts such as counters, timers, and using the integer data type. Without further ado, let's jump into our scene. Okay, so first things first, we are going to go into factory I/O. If you need to install factory I/O, you can go to my previous video where I covered that and getting that all set up with CodeSys. We're just going to jump into scenes here, and we are going to go queue of items counters. This is the one we're going to be working with. We're skipping over the tank for now, but there's a nice scene that we're going to deal with later in the series. I just want to cover that after we get through some of these conveyor belt problems. So here we go. We have our emitter here. We have our remover here. And we've got 3 sensors, 1, 2, 3. What we can do here actually is we can go into view and we can click dock all tags. And it shows us what we have available to work with. We can also use the keyboard shortcuts I and O, and that brings the labels up so you can see what everything is supposed to be doing. So just like last time, we have this conveyor belt, and yes, we can just drive it off the sensors. What I prefer to do is to have it more closely mirror what we would see in the real world. So in a factory setting, you would have obviously some way to manually operate this. So we're going to put in a column here, put in an electrical box. Electrical box doesn't actually do anything, but it's aesthetically pleasing, I guess. We'll throw in, what is this? Is this a start button? Yes, this is the start button. We'll throw in a start button. And if you need a refresher, on how to move things around, it's mostly just click and drag, but for moving things up and down, you need to hold the V button, and then you can move to different heights. So we'll put that there. With the buttons, you can change your colors. If you right click, you can go down to color, and we'll make this green for our start button. We've got a stop button here. Flip this around, and where's our stop a reset button? That's what we want. We want a reset button. Okay, so place that. We got 3 buttons. Always need an e-stop. Safety first. Place in an e-stop, and we're actually going to put in one of these digital displays, and we'll get into what we need that for in a moment. Flip that around. We are going to configure this, so right click on it, and we're going to change this to integer. So this is going to display an integer value. We have these other configurations. You can display a voltage from 0 to 10, negative 10 to 10. I'm not sure what BCD is. I'll look into it, but for now, we're just going to be using integer. Okay, so we got an electrical panel set up. We got some buttons, our displays, everything we need to make an actual machine here. Now, if we go over to our dock tags, we can actually dock our new tags as well. So we see all of the new things we've just added in are there. But we're going to unforce the emitter. I want to have some level of control over that, so that the machine isn't just doing whatever it wants. We are going to actually control it. Remover, I'll leave that for us. When the boxes are off the conveyor belt, it's not our problem anymore. We're dealing with this cell here and nothing past it. But we do need to grant permission for objects to enter our cell. So that's what we're going to do. Okay. Let me just drag CodeSys over here. I was playing around with CodeSys a little bit earlier. We're going to create a new standard project. And that is going to be scene 2 LD for ladder diagram. Standard project, okay. Ladder logic diagram. And just like I said in the first video, make sure you're not on the ladder diagram. You want to be on the ladder logic diagram. This one has more functionality. Go ahead and select that. Device can stay the same. And we'll populate a new project. All right, so let's click into our main program here. It's PLC PRG. And we're going to want to rename this just to for later on in the video. When we go to import our variables, we want something kind of unique so that factory I/O doesn't pull in variables that are like hidden in our software. Like CodeSys has its own variables. Some of them may have PRG or PLC in their names. So we're gonna rename this to something unique. Let's go S2LD, scene 2LD. Actually, I don't even think this is scene 2. I think this is like scene 4 or something, but this is what we're calling it, scene 2LD. That's going to be our program there. And a good place to start is we can start adding in our variables. It's actually nice if you name them pretty much what they're named here, and then that way everything stays nice and consistent. Let's move the toolbox over there. And it's nice to have these side by side. Scooch out the name field a little bit. And let's just start adding some stuff. So we have at entry, that's our entry sensor. We have at exit sensor. Buffer conveyor. And I'll just go down the list here one by one. I don't think you need me to walk you through every single one. Oh, except for this one. Oh, okay. Digital display. So the digital display is going to be driven off of a variable that we're going to create right now. So what we will call the digital display. This is going to be parts buffered. And we just need to take this data type here, because this is going to be our integer that we're working with. One of them, I think we're going to need a couple more integers than that, but this is the one that we'll be displaying to our display. So I've actually gone ahead and I've already solved this one, so I have my list of variables that we're going to need to use already pulled up. So I'm going to go ahead and type those all out, and you can copy them as I go along, or actually I'll fast forward this part, and there'll be a list of variables that you can add in afterwards. Okay, and this looks pretty reasonable. If there's anything I missed, we'll add it in later, but there are a couple extra integer variables that I've set up here, so take a look at those. We have 3 sensors. Let's take a look here. We have our 3 sensors, 1, 2, 3. So I've made 3 variables. We're gonna be able to count how many parts have passed each sensor, so we can better control the system here. We're only going to display just the one value, which is going to be the parts buffered. So the goal of this system here is we want to bring 3 boxes into this buffering area here, which is this area between these 2 sensors where the electrical panel is. So we want to bring 3 boxes into there and then move them on to the next station or dispose of them, whatever you imagine your big factory to be doing. But bring 3 boxes in and dispose of them. What I want to happen is I don't want the emitter to emit after I've got my 3 boxes. Until it's ready to queue up another 3 parts, it's going to stay inactive. Some other things we want to do, we want our lights to light up on our buttons. If you click on those, you can press play here, and you can actually interact with these. And there's a light attached to each one of these that we can set up. Have it function like an actual control panel. And we want our e-stop obviously to work. I want to be able to purge the system. So let's say that there is some sort of jam. An operator goes in, they clear the jam, and now the counts and everything, they're all messed up. We want to just be able to purge this and start fresh. So when we hold down the reset button, I want that to reset all of our counters, and I want it to be able to move the boxes along the conveyor belt and completely clear the system so it's ready to start again. And that's what we're going to aim to do. Let's go back to CODESYS. We got all of our variables, or most of our variables probably. And we will start putting this into ladder logic. So the first thing we probably want to do is to get our conveyor belts working the right way. We can expand upon the logic that controls them as we go, but let's at least get them started. So what we're going to do, we click on our first rung, our first branch, program, whatever you want to call it. So we'll add in our coil here. This is going to control the entry conveyor. And what do we want to control the entry conveyor? Well, let's say we want the e-stop. If the e-stop is depressed, we want it to not run. Oops. What did I originally name e-stop? I didn't add e-stop. That's a good one to forget. E-stop. Where is it? I'll just add it. E-stop. That's going to be Boolean, true or false. E-stops are normally closed contacts, so by default, before you press the button, it is able to pass current through it. So in this configuration, while the e-stop is not pressed, it will power the entry conveyor. So that's one input we want to control the conveyor. We also probably want the start button perhaps to control it. But this is an interesting thing. So if we can either use this coil as a set and reset coil, and we'd have to add another branch for resetting the conveyor. So that would be you press the what is going on with this? We're just gonna we're gonna delete this and start over. Something's a little funky there. Add a new program here, and let's go ahead. We'll add in our coil. I think it was because I was messing around with that e-stop variable. This is going to be our entry conveyor. And we're going to add in a contact for the e-stop. Okay, so that's one. We want the start button to start this. And like I was saying, we can either do a set and reset setup with you'd have two different coils here, one for setting the conveyor to on and one for setting it to off. What I don't want to get super deep into that kind of set and reset programming. Let's just leave it as is. While these conditions are true, this is on. If they're not all true, then it's off. So let us do something different instead. We're gonna make a new. Want that below. We're gonna make a new branch here, and that is going to be for the start light. It's gonna be. We're actually gonna make this a coil. Coil is going to be start light. And what would power the start light? Well, perhaps the start button. So if we press the start button, the start light will activate. But the start light will turn off as soon as we release the start button. So what we can do here is just like we talked about in the first video, we can make the start light also a contact. So when you press the start button, momentarily the start light comes on, but now because the start light is on, the start light will keep the start light on. So that is a way to use the same variable as a coil and a contact, a load and an input, to keep itself running. We want a way to turn this off, so we're going to put in an e-stop here. E-stop is always a good way to turn something off. Stop button would also be a good one. Stop button is similar to the e-stop in this case. It is normally closed contact, so by default, it's passing current through. When you press the button, it actually physically breaks that connection. So we have our start light here. We got the e-stop, the stop button, and if we wanted to reset the device, we would also want that to stop the conveyor belt. So let's put the reset button in here. Reset button is not like the e-stop and the stop button. It is a normally open contact. So we actually have to flip this here. If we want it to, like by default, be passing current, we need to flip that to a negated contact. So what this is saying now is if either the start button is pushed or the start light is on, and the e-stop button is not pushed, and the stop button is not pushed, and the reset button is not pushed, then the start light will be activated, which starts the start light, and back and forth it goes, keeping itself on. And we have these three ways to break that connection. So e-stop here, I like to just put in the e-stop and the stop button on my loads so that they shut everything down as they should. Another interesting thing that I think we should talk about is how to set up your coils. I like to have each one of these programs, each one of these rungs of my ladder logic deal with one coil. So every load should only be referenced one time in your program. The way ladder logic works is that it's going to read from top to bottom, and whatever the bottom value, whatever the latest value that it finds. So if I had another line with start light, and the first time it reads on, but the second time it reads off, well then it's just off. So if you keep your loads your coils one per line, then you won't have conflicting information, and it keeps your program nice and simple. That is everything for the start light logic there. And we're going to use the start light to kind of indicate to our system that yes, it is on. Start button is a momentary actuator that the operator uses, but then the start light is pretty much going to be the variable that tells the machine that it's on. We have the start light, and let's get back into the entry conveyor. Let's drag this down. We have our e-stop, we have our stop button, and we have our start light now. Start light is now going to tell the machine that it's on, and as long as it's not being overridden by the e-stop or the stop button, it'll run the entry conveyor. Now, there's something else to think about, is when do we want the entry conveyor to be on? We want to cap our system to handling 3 parts at a time. So we don't want the conveyor, we don't need to be pushing parts in after the conveyor belt, our conveyor belt system already has 3 parts on it. So here's where we're going to start getting a little bit into math operators and in our new integer data type. And integer, just for a recap, that's 1, 2, 3, 4, just whole numbers, no decimal points. You can look into what number ranges are available for a data type. There's plenty of resources online for that. We're going to put in a less than command. So we're putting in a less than command because we only want this conveyor belt to run, because this is the conveyor belt that pushes parts into the system. A part's dropped off here, and then the part is pushed into the buffer conveyor. We only want that to be emitting parts and pushing those parts in when there are less than 3 of them. When we hit 3, that's where we want to cap it at. We're going to come back to here. And what are our integers? Our integer variables. We have parts buffered, so that's not going to be the one. Parts on belt, yep, that's the one. And parts removed. So parts removed is how many parts it throws off the end of the belt. Parts buffered is how many we have in the buffer zone, and parts on belt is including all of the ones that we spawn with the emitter. So parts on belt. The input arguments here for the less than operation, these are in math operators. They are, I believe, integer, real, any numerical value. The less than operator deals with numbers. I think that's pretty obvious. The first one, just think about it. Just think about it in your head. If parts on belt is less than 3, so the top one comes first, the second one comes after. Parts on belt less than 3, then this is true, and then it opens up this gateway for the conveyor to be activated. So if parts on belt are greater than or equal to 3, it will block this branch. This branch will not activate if it is equal to or greater than 3. Now we are going to remember how we said we wanted to have the reset button be able to clear the entire system. That would be another way. That would be another scenario where we want the conveyor to run. So we're going to put a contact down below. That's going to bypass all of this logic, right? And reset button. So if we're holding down the reset button, that will trigger the entry conveyor. And then we can manually clear parts. So a little bit more room here. Next thing we want to look at is the buffer conveyor. We dealt with the entry conveyor. Let's go into the buffer conveyor. And the buffer conveyor is going to have some more conditions. First of all, let us actually set this up and see what happens with our machine here, because I think we can run it in this state. Like before, we are going to create a symbol configuration so that we can pass all of these variables onto factory IO. Let's build our program. S2LD. We're going to pass all of these variables over to factory IO. I always click build again for good luck. And then let's go set up our device. Scan the network. I already have this running because I was playing with it earlier. Just remember to go into your tool tray and right click on this little cube that says 64 and start your PLC. That adds this device to your network, and now we can connect to it. Okay, so we connect. If you have credentials, type them in. Yep, that was my previous application. And we'll hit the play button up here. And now our PLC, or our program here is now live. We just need to go ahead and connect this to factory IO. So you can either go file and then click on drivers, or you can just use the keyboard shortcut F4. We're going to select our OPC client, and we'll do some configuration. Select your server, which is our CODESYS server. That's this fellow right here. And we're going to browse. We named this S2LD. Browse for our variables. And when we come back here, we can see that they're all lined up on this board. Exit. Just start plugging them in. As long as we don't add new variables, we can just go ahead and update our ladder logic as much as we want without having to replug these in or add any new variables. We can just update our ladder logic and try stuff. As long as you're not adding new variables, you won't have to redo the symbol configuration and all that stuff. What do we have here? We have e-stop we want. There we go. Item ready. It's already done. Reset button. Start button. Stop button. And now we'll do our loads, our coils, our actuators, whatever you want to call them. Buffer conveyor. Emitter. Entry conveyor. Digital display 0. We want to plug that in. Where's our digital display? I believe we were going to use, yes, parts buffered. That's the one. Remover, we don't need to plug in. That's forced. Reset button light. Start button light. And stop button light. So I think we have everything plugged in. Make sure this says disconnect, and you got this little green check mark over here to make sure that you're plugged in and connected. And we can actually turn this on, see what happens. So it's emitted apart. I don't think we put in any emitter logic yet. Well, let's hit the start button and see what happens. We did code that in. The light comes on, and the conveyors start moving. Ooh, look what's happening here. They're all bunching up. That's because the buffer conveyor hasn't come on yet. So sure, we could put 3 boxes onto the buffer conveyor by just ramming them into each other, but let's make this a little bit more elegant, okay? Back to CODESYS. We're going to log out of this. So let's add our buffer conveyor logic. So far, everything seems to be working. I could have tested the start button, stop button. Actually, we've logged out here, which means that this isn't going to these variables here aren't going to update, but the factory IO should still be running on the logic that we just uploaded. So yeah, pressing these buttons breaks that connection just as we programmed. Each one of those buttons is working to break the connection to the start light. And CODESYS over here. From there, we're going to add in our buffer conveyor. So I've worked a little bit ahead. I've got the solution in front of me, so I'm just going to go ahead and do it because it can be a little tedious to go back and add more branches in CODESYS. So if you don't have everything clear in your head right now and you're wondering how I got here, it's because I did spend some time messing around with this and figured out a solution that worked for me. So don't be worried, but we're going to add in some logic here. We need 3 branches. There are 3 different conditions that can activate this buffer conveyor. So we got contact 1, contact 2, and add another one, contact 3. Well, what are these conditions? We saw that all the boxes bunched up here when they came off this is 2 conveyor belts. That's one there. That's one there. At that transition, one of them is pushing forward, the other one is not. So it's kind of just the boxes will just get rammed into each other, and that's how they're going to be moved onto the buffer conveyor. We want a nice gentle handoff. So conveyor 1 is going to be on. When this sensor is tripped, then this conveyor is going to come on and let that box off of the entry conveyor. It's going to gracefully bring it onto the buffer conveyor. So we'll do it like this. We're gonna have our same, e-stop. I'm sure there's a more efficient way to put these in. Stop button. Am I missing anything? The reset button. Actually, I'm going to leave the reset button out just because we're going to be actually controlling the buffer conveyor with the reset button. Oh, we'll put it in. We'll put it in. See what happens. Reset button. And we are going to put in a contact for our quote unquote at entry sensor. So at entry. Because these are retroreflective sensors, they are by default on. The light is emitted from the emitter. It bounces off the reflector plate, and then it's read again by the sensor. So it's got a default on signal. We want the signal to go off. So when a box gets in the way and interrupts the signal, then that will be the desired condition. So when the sensor is off, we want it to give us power to the conveyor. So that's why we have that there. We are going to add in e-stop again. If you are familiar with a more efficient way, please let me know in the comments how I can more efficiently put this stop button, stop button, e-stop, all those kind of buttons, that logic. I think maybe I could make a POU for it. I can't remember exactly what POU stands for, personal organizational unit or something silly like that. E-stop, stop button, and when the parts in the buffer conveyor are 3, so when there's 3 boxes on the buffer conveyor, we want it to bring them over to the exit. So while these are equal to 3, so we take the equal command, the equal function block, and what did I call it? Parts buffered. While parts buffered is equal to 3, then buffer conveyor is going to be active. So even when there's no box at the entry sensor, it's going to send that through. Reset button down here. This is for our reset button, manual clear functionality. Add the e-stop. Oops. Because if the e-stop's on, we don't want the restart button to override it. That's why we have that there. If you had the e-stop on and you could still turn the machine on manually, that's bad news. So make sure that the e-stop is also overriding the reset button. Even though the reset button's manual, if it needs to be shut out, then it needs to be shut out. So I think that is enough to begin testing. Actually, one more thing. There's something missing. If you're just learning PLCs, maybe you don't know what that is, but if you're more familiar, you'll know that we have these variables, parts on belt, parts buffered. They're variables, they're integers, but what updates them? So right now, these are just, I think they default to 0. You can also choose a value to initialize at. If there's no predetermined value, it'll initialize to this value, and we can set that to 0. I think that's a nice place to start for all of our variables. But there's nothing that will actually perform the counting function yet to increase our variables. And all of this logic is based around knowing how many boxes are on the belt, how many boxes are in the buffer zone, et cetera, et cetera. So let's add in some counters. This is a new function for you. Add in a new line here. And we can go to, where are they? Function blocks? Yeah, in CODESYS, they're called CTU and CTD. So CTU is counting up, whereas CTD is counting down. I believe there's also a function for counting up and down. Don't quote me on that. But let's plop one of these in here. So we're going to count up. So it asks you to make a variable. We don't actually need to pass this variable to factory IO. So we can add this variable here, and we do not need to pass it to factory IO. As long as it's communicating with CODESYS here, CODESYS will handle the memory and the updating of that variable. So we don't need to pass our counters over to factory IO. So we need to figure out what kind of behavior we want to trigger this counter to increment. This counter, we'll say it. We can say that this increments at entry. No. What was the first one? What was the very first one? Parts on belt. Increment on belt. So this is all of the parts that are on the belt. That's what that counter is. So we should go in here and we're gonna take a look. We have this item ready sensor. Item ready sensor. So every time that sensor flashes, that means that we've added a new part to the belt. So that was the it was the item ready sensor. Item ready. And we have a reset button for a reason. We're going to use the reset light though. We'll get into that in a little bit. Okay, so what we have here, we have the sensor which initiates the increment function. So this is going to add 1 to our value. We have the reset light. We're not going to use the button to reset this because we're not going to be physically pressing the button every single time. Rather, we are going to use the reset light to hit all of our reset functions in our counters. PV is your preset value. We are trying to output an integer, so we just want an integer value as our preset. If there's anything that happens after this, you can chain a bunch of things together. It's not necessary, but you can. So what we are going to do is have all of our counters just one after another, each one having its own line. CV. So this is the variable this is where it's going to export the current value to. CV, current value. So we want that to export to, where was our variable there? Oh, parts on belt. That's right. Parts on belt. So this is the total number of parts that are on our belt or roller system. We have another one there. We have parts buffered. So we're going to copy paste this line. And this is going to be inc parts buffered. Yes. And we want it to send to our parts buffered variable, parts buffered. The reset light's going to be the same. The reset light's going to hit all of our counters all at once. That's how we're going to restart the whole thing. But we want a different sensor to update our parts buffered. Parts buffered is this second belt here. So this belt's not telling us this sensor's not telling us what's on that belt. This sensor will give us a better idea of what's on that belt. That's our at entry sensor. So we'll go ahead and use that sensor. At entry. Reset light, preset value, parts buffered, and we'll add our last counter here. Our last counter is going to be the exit one. So we want to know how many boxes fall off of the conveyor as well. So at exit is going to be our sensor, reset light like normal, preset value 0, and current value is going to export to, where are we here? Parts removed. So whenever one of these boxes falls off the end of the conveyor belt, it's going to trigger that sensor and tell us that the box has come off of the sensor or of the conveyor belt. So think this gives us something to test here. We can see if the buffer conveyor actually turns on when the parts equal 3. We haven't done our emitter logic yet, so it's going to keep emitting parts. That should be okay because we have done our entry conveyor logic, so it's not going to push them all onto the buffer. Let's log in with our changes and have a look. Okay. Don't think we added anything new. If you aren't sure if you did add anything new, you need to plug it all in. You can go into configuration here and just hit the browse button on items and nodes. And it won't delete everything, but it will add more variables if you've added more variables. We'll go back here. Okay, let's hit the start button. Okay, so what happened there? Reset button's working for clearing. We haven't set up the light yet, so it's not resetting this count value. But you can see our count values down here on the digital display, so that's good. Let's reset this. If we press the start button, it should start doing stuff. What is it doing? I think we might have a mismatch with something here. You see parts on belt is already reading 3. That's because our reset button's not doing anything. So, or our reset light rather is not doing anything. So we'll need to add some logic for that before we go any further. We got our counters, we got our buffer conveyor, entry conveyor, and our start light. We need to go a little bit further before we can verify that everything's working as it should. So let's add our next branch in. Next branch, please. Thank you. And this coil, we're going to deal with the emitter. Got the emitter here. We are going to do something a little special in this one. Obviously, we're going to put in our e-stop. Obviously, we got to put in the e-stop. Safety first. And stop. Ugh. Sometimes that happens. You'll start typing and it'll say, oh, that's a variable. You just gotta stop. Just cancel out of that. Stop button. This one was a little bit funky. I remember I did have some problems setting up this rung, and I had to do some experimentation. So I'll jump you through to the final product here. If the emitter, so if you have, let me refresh. We want the emitter to put a new part onto the belt if there are less than 3 of them. Once there's 3 parts on the belt, we don't want any more. So we're going to go into our math operators, and we're going to stick a less than operator here. So if parts on belt, if parts on belt is less than 3, so once it hits 3, it's going to stop. The emitter is active. But the other thing we want to happen is we want the ability to stop the emitter. We want the ability to stop the emitter. Where's my function here? All right, there we go. We want the ability to stop the emitter when we're doing our manual reset, kind of purge function. We don't want it to put out more parts. Otherwise, you'd be infinitely purging whatever it spits out at you. So we need to turn off the emitter while we're holding down the reset button. Stick our reset button there, and we're going to stick the emitter coil here. Emitter. Now, this is why I say I thought it was a little bit odd. Typically, I would just want to have the emitter referenced once because it's a load. I only want it to be driven in one line of this logic. But we're going to branch this off here. So if the reset button is pressed, it's going to set the emitter to off. I tried using the negation coil. So the negation, it looks like this. That didn't seem to be working, so I did have to resort to using the reset coil. So what the set and reset coils do are, if you get even just a short pulse, it will set the coil to whichever state. Set is on, reset is off. It will set it to that state until it receives new information about its state. So you can press the reset button for a second, and it'll hold it off for as long as it